Hello and welcome to our presentation for our RIGPR project representing the team for Frontier. As you know from our previous video, we were tasked with making a sandbox management sim that has a few different requirements listed here. We were very fortunate having the freedom to choose our theme and key selling points.
Welcome to Curation, a museum management simulator. Create and build the newest museum in town, a place of science and history, wonder and mystery. Construct your dream exhibition by buying and displaying the rarest artifacts from all corners of the world and beyond. Balance your venture to maximize fun, manage costs, and minimize whiny customers that get tired after seeing just 3 rooms. Exactly like a real museum, this is Curation. Curation is the culmination of the team's efforts, comprised of a diverse collection of features, assets, and mechanics. Here is some of our work and how we created our game.
As of the making of this video, all of our prerequisite deliverables have been achieved, including our concept pitch to Frontier, our documentation for all disciplines of our teams, and a full release pitch of our concept that includes a demonstration of our fully playable prototype. We have also created 2 trailers, 1 cinematic and 1 gameplay, in order to showcase our final product to any future promotions of our game, which we will now play. Please enjoy. Across the entirety of development, we conducted regular playtesting that used feedback to change the game as we were making it. As shown in the research by Mirza Babai et al., regular playtesting is very important for indie studios as it helps developers to refine the game's design and the user experience, which improves the accessibility across a player base. For our research, we conducted on a range of roughly 20 people across development, with a large range of both game knowledge and previous playtesting for our game. For those with a greater understanding of our game, we took in feedback in regard to the flow and pacing of our game, overall engagement and key engaging areas, and how our game feel compares to that of industry release titles. while playtesters with less experience gave us feedback relating to the overall accessibility of our game from both written feedback and visual analysis of their gameplay. These resulted in key additions to our game, such as the hint system, that periodically shows hints to guide the player when playing our game, and a controls layout in the options menu. We will now talk in detail about the features we added, our processes for deciding them, and reflect on the methods used within each feature. When we moved into the development period, we created a feature set to refer to for what we wanted to include in the demo. To do this, we broke down the deliverables from the brief we were given, as shown on the right, into these specific requirements. Some of these are not completely specific and would require multiple features to fulfill. To better break down our task, we created multiple documents based on our analysis of our deliverables and the feature set. These being a feature list, which was influenced by our design team and planned prototypes and the requirements, and an asset list which takes features from the feature list and populates the art required for them, alongside accounting for design-driven theming around the art style. These lists have integrations with our project management style, being directly implemented into Jira's tasks, and including related tasks that need to be completed before or in tandem with that task. There are also efforts to control the scope with specified priorities and sizes of tasks, alongside marking some of the tasks as stretch goals to not introduce feature creep into our game. Now we will go over our individual features and detail their designs, developments, and outcome, starting with the user interface.
The user interface was one of the main deliverables set before us by the client, and it's my belief that the methodologies used to develop this feature were both appropriate and necessary to get this task done in time. Our approach to making this feature focused on user-centric design, particularly with an emphasis on making the construction mechanics and general user experience feel frictionless. This was quite an undertaking, because the UI ideally should connect to almost every single important feature in the game, and for that to happen, the UI had to be cohesive and seamless enough with the game framework, so players don't encounter hurdles to their goals. Informed by research we performed in Teaching Block 1 and content from new university modules, we have achieved this pretty well. Particularly, sub-features like dynamic elements further complement this goal, as guidance, hints, and prompts can be fully contextual, and this ensures a base level of clarity with the game's interface. Additionally, to support players of all kinds, these dynamic elements were also leveraged towards providing clarity on actions, like cancelling a object placement or showing the price of a wall being dragged out. We understand that players may be unfamiliar with the genre, so by not only providing a keybind but a physical button, a dynamic button as well, we enable the player to learn and play the game their way, which also aligns with the game's pillars of creativity and building your own museum how you like it. Supporting overall clarity, the UI is fully interactive and feels extremely tactile to work with. We also incorporated researched UX practices, such as those detailed in the game accessibility guidelines, and further knowledge coming from Teaching Block 1, such as research on semiotic domains. We also examined the game UI database to ensure that the text, iconography, and the wording of certain buttons is understandable to anyone coming to play our game, and this was all reinforced by QA testing. Reflecting overall, we believe that our methodologies were appropriate. Especially with regard to icons and assets, universal standards were enforced to keep the UI lightweight, legible, and clear. This approach was educated by a bunch of different sources, such as the WCA guidelines, accessibility guidelines, and HUD research, or even Google's design system, Material Design Free. We did encounter a few problems during development, particularly with blocked tasks. The UI was very held up by other features being unfinished, and this led to the interface taking nearly the entire length of the project to finish. However, understanding that this is a normal part of game development, we adjusted the workflow and the creation of UI so there's more emphasis on scalable elements and reusable elements. What this meant was that the rest of the team could easily call the UI on the fly, and rather than coding specific support for a given feature, menus in their areas were designed to adapt to inputs so that once a feature was conceived, the UI could easily be tailored to that framework with minimal work. If I were to change something about its development, I would say that this could have benefited from more interdisciplinary teamwork. The actual conception of the UI was handled by a single member of the team, and the risk of burnout is always present with overburdening one person with tasks. A good example of where this actually affected us was when we ran out of time to produce all the icons needed, and instead had to implement royalty-free icons for artifact categories because we ran out of time. This could have been avoided if the workload was taken on separately, and this serves as a good area for improvement for us next time. The settings system was also really great. Accessible both from the main menu and in-game, it boasts a wide range of settings, whether that's VSync or audio controls or even hints. A lot of these settings were heavily guided by our client's input, but also was supplemented by the same accessibility guidelines that we used in the user interface. Some hallmarks of the accessibility options include the color blindness setting, which toggles a pattern on colored objects so players know exactly what a given object does. Additionally, to compensate for different devices, we added camera and mouse sensitivity following QA feedback and changes. Again, though, the settings menu had a reliance on complete features and ended up being done within the last few weeks of development due to this. It was also slightly overscoped, and the number of settings planned was heavily decreased to keep pace with the finish date. Development of this feature could have been a lot smoother if this was started earlier, and if the workload for systems like the UI was spread out. Therefore, in the future, it is of great importance to make sure that, again, the work is spread evenly, and that everyone is committing to make the development easier across the board.
The main purpose of dressing the scene is to provide cover for the edges of the game space. To do this, a forest of trees spreads out in 3 directions, with a large rock wall in the background that provides diversity to the scenery and game space orientation at the same time. While these decorative background objects prevent the camera from seeing any empty space, they also had to be mindful to prevent any of the play space from being obscured. To differentiate this background from the active game space, a lighter shade of green for the grass was used, and this was to show the player exactly where their bounds reached without having to explicitly tell them. In order to maintain the appearance of organic scenery, no grids or measurements were made when placing the trees, and only a generalized item density was kept to prevent bunchings and clearings. In the initial implementation, performance dropped significantly from the older builds, and this was most likely due to the amount of assets on screen. The majority of them were small pieces of grass, and once they were removed, the game ran much smoother.
The tutorials and hint system were added towards the end of development, as our playtests had had a number of players stumped, especially when creating the first parts of their museums. This led to the introduction of the hint system, where short bodies of text are displayed in the corner of the screen, aiming to guide the player to the next stage of progression within the game, although some are a bit more tongue-in-cheek. A menu option allows hints to be turned on or off, although clicking the icon in the top left will always display the most recently given hint. The code was originally created by George, but I iterated upon it to allow for much more scalability through the use of scriptable objects, so a developer would only ever have to input the absolute minimum, which is the title, the body of text, and then a short string which is used to call the hint. The use of a static method allows hints to be called from wherever in the code, and once these have been called, they can never be run again. So a hint will only ever display once, and also there is a queue system, so if multiple are activated within quick succession, only one will display at a time. We did run into the problem of hints not being accessible once they'd already been displayed and overwritten by a different hint, so we wanted to create a backlog, but unfortunately this wasn't feasible during the development time we had left when the system was added. If this were to be added, it would greatly increase ease of use.
The chosen camera perspective for this project was isometric at a 45-degree angle. This provided aerial views while retaining the details on each object, like a drone moving around a space. An orthographic view was also made available for more precise wall and object placement as a quality of life feature after feedback from the playtesters. Controls for both movement and rotation are available on both the keyboard and the mouse, as this is a preference for each player, some of whom interchange. They can be used at the same time as one another, but the mouse takes priority over the keyboard due to the higher degree of control it provides. For zooming, a minimum and a maximum distance exist to both stop the player from moving all the way up close to the ground, but also to prevent them from being able to see outside of the set scene. The forests and cliff are built according to this upper boundary. When moving the camera to the edge of the available playfield, it will slow to a stop, preventing the player from leaving. This is once again to keep them within visual and actionable bounds, but the added step of a softened stop was added to prevent a harsh jarring effect that clashed with the overall smoothness of the game.
The grid was a system planned early in development to be the foundation of our building systems. It was designed to be easily expandable and efficient, which was done by making it a static general class, meaning that there are no continuous update functions that would be called during gameplay, and method and members could be easily added to it and be called from any class. It makes use of a dictionary of a cell class, indexed by vector2 ints for efficient searching through cells and reducing the memory needed to store them. Finally, being a major static class, it includes many functions relating to the grid, including various updates, adding and removing objects and walls from the grid, and mathematical translations between different vector types and local and world spaces. In use, this class was built upon across various systems and became a solid backbone of the game with very few issues. The main noteworthy problems was there were some minor redundancies which led to very long lines of code in some cases, which affected the readability of the codebase to the developers. This could easily be fixed in the future with some name changes and reorganizing the class in ways such as splitting into separate classes or moving methods to more relevant places. Another thing that could need changing is the static persistency that we discovered later during development, as the grid is never unloaded when the game is opened, including on-scene change, which we did not expect and led to a few issues. We need to carefully track when data is stored into this class and purposefully clear them in different scenarios, such as when moving to the main menu. Overall, the grid was a crucial feature during the development of the game and was very useful in tying various systems together. When adding the ability to create objects, we specifically planned it in a modular way to make it easy to add new objects and change existing ones. This was done through an object dictionary with a custom scriptable object, which allows a developer to set the visible information, alongside parameters like collision. After some QA and feedback from developers, this was expanded on by Ollie to be a simple process as possible to reduce the time it takes to input values like the collision. The object placement methods use invectors and rotation, using quaternions, to determine the current location of the object based on the player's cursor. This makes it simple and efficient to calculate positioning and was easily able to merge with the grid system. Finally, satisfying and intuitive visuals were added to the placement systems. These were changed various times and improved via the design team and playtesting, and it resulted in a clear preview of the object that smoothly transitions when moving and placing an object. The system went mostly unchanged other than additions of sound and implementations of other systems. However, one area that should have been changed was a manual method to create an object at a specified point from anywhere within the code. This is a change that would be crucial moving forward and would be done by moving the code elsewhere, such as a new method or class. For walls and rooms, we decided instead of limiting the player to rectangular rooms, we wanted a building system that allowed rooms of any shape. This was done by using a flood fill algorithm to determine if a room exists, by using the border of a playable area as a check to ensure no rooms spawn outside of a building. This also meant that room sizes had to be limited so calculations were reduced, as the processing time of these calculations scaled exponentially with size. Walls were handled in a similar way to objects by implementing themselves into the grid system. However, both placement and the result of walls placed were intuitive during initial playtesting, as players would be confused as to how to manipulate walls correctly. This was fixed during development by modifying the collision of the cursor on the walls and adding the ability for placed walls to split and merge with existing walls, so any options for the player to remove or add walls were possible without any extra steps. Wall painting was added later during development and had a few issues with material Z-fighting, as seen here. However, precautions were put in place to paint segmented walls equally and was made expandable similar to the object placing system with the addition of a material database. There are still a few problems present with the current wall and room systems, specifically when deleting walls and rooms, which would need a lot of attention if development was to continue. This, combined with object placement, would also need to properly account for a saving system, which currently doesn't exist but is a much needed feature. That being said, the current state of building is very satisfying and easy to manipulate into building whatever you want, which was what we intended to accomplish and reaffirmed by our playtesting and our pitch to Frontier.
The time system is fairly straightforward and follows the familiar format found in management sims. It also serves as a means for other mechanics like AI or the day cycle to function within the game world. The initial layout of the time frame was slightly jarring to current players, and following the concept of the mock-up in Teaching Block 1, we heavily revamped it into something that was more streamlined. In later stage external QA efforts, we received some really insightful feedback from a fan of the genre. While the UI was great and still relevant, many business sim games tie speed control to certain keybinds, something that we missed during our research. Following this, we implemented changes to set speed on the fly, using space or numbers, and we saw a significant improvement in the adoption of time control and an improvement in the player's ability to make decisions. Overall, this feature achieves what it's set out to do. It's a fairly simple system, but the way it's been iterated upon definitely serves as a testament to how good QA can really be. And it can really help bring your game to the next level by assuring that next bar of quality is met.
Following the Christmas break, an initial NPC prototype was developed which focused purely on functionality and optimization. The original plan featured frame, tick, and turn splitting of functions, which should allow each NPC to only calculate what they need to do an appropriate number of times, which are then staggered over a course of a number of frames, so you could have a lot of NPCs calculating at the same time, but the most costly processes were only performed on a handful of NPCs per frame. A desire system allowing for autonomous actions, which is calculated on the turn update, which is about every 25 in-game minutes. This is a good compromise, although there can be slight delays when they see a panicking NPC, for example, making it potentially a little unintuitive. To combat this, I had to tune the turn time so that it felt responsive without being too costly on performance. The initial ideas to split functions and how to optimize came from a game developer article about creating crowds in Planet Coaster, another game made by Frontier Developments. Whilst a lot more advanced, it helped me develop a kind of framework for how I would go about implementing certain features, such as the frame, tick, and turn system, in order to alleviate the stress of running hundreds to potentially thousands of operations every frame. The wander, visit, donate, and leave desires are selected based on a number of factors such as artifacts seen and their desirability, happiness determining propensity to donate, and leave originally just being a chance that increased with each turn that the NPC was alive. Enter is the first desire when an NPC is spawned, leading the NPC to a specific location which is marked as the entrance. Panic is a contingency that activates when an NPC is trapped within the museum and their path to the exit fails. This was to stop players from trapping the NPCs and making them infinitely wander the museum. The values for this random desire selection are hidden so that it doesn't overwhelm players. The nav mesh was to dynamically update around placed items. This does, however, run into slight stutter on lower performing computers, but is mostly unnoticeable. The work required to mitigate this would have been incredibly complex and not feasible within the scope of development. A custom navmesh agent implementation was used over the inbuilt one, as it allows me to only calculate the path once every turn update, and also when the navmesh is regenerated when something is placed down, compared to the inbuilt which constantly calculates a path for the NPC moving in the scene. At larger scales, this causes a lot of stutter with the movement and they look very janky. It should also be noted that I had a conversation with Kian Bennett, the programmer from last year's Maltopia project, which was a very similar project to ours. He helped me get introduced to the navmesh agent and navmesh classes, as well as dynamically updating them around the in-game objects. Their memory is based on real-world sight, using raycasts every in-game tick, which is about every 5 in-game minutes, to update their memory. They can also see other NPCs and will panic when they spot another one panicking. Artifacts have types and values, which give them their hidden desirability score. NPCs have a specific type that they're interested in, which is more then desirable to them. Each artifact has a number of interaction points, which are in all of the cardinal directions, which allow the NPCs to go and visit in the first place. The prototype also contained the first iteration of the room detection algorithm, which was mentioned earlier by Ethan. As possibly the single largest system in the game, creating a prototype effectively helped me to establish the core NPC subsystems and communicate with other designers and coders as to what this final system might look like. In addition, the client was very happy that we had kind of tangible progress by this point, where it was very much prototypes, but it showed that we were getting on with the project relatively early on, because this was created again around January. While this was effective at establishing the kind of core ideas of the project, there were a number of unscalable decisions, such as the FSM-based implementation, which was fine for what I needed it for during the prototype, but taking it into the actual project wouldn't be feasible, especially if we wanted to expand on any of the behaviors. This was because transitions between states were quite janky and very much hard-coded. Therefore, at larger scales, this would be incredibly unintuitive for any other designers coming to work on the project or even coders. In addition, a couple of the tasks were performed redundantly, so there was an entire A-star pathfinding algorithm that was within the code that was used to only validate the path from A to B within the grid, which was entirely unnecessary and could have been solved a lot earlier and a lot more simply if I had just read the Unity documentation on the navmesh agent class. The final NPC system was based on and lifts a lot of systems from the prototype. However, the entire codebase was rewritten to be vastly more scalable. This was achieved in part thanks to behavior trees, where an activity for the NPC, so for example a desire, is represented through a series of nodes which are strung together to create a behavior. For example, to wander, an NPC sets their destination to a random position, it calculates a path to that position, moves to that position, and then sets their desire to wander again, or will calculate a new desire if it's a turn. If this fails for any reason, mostly down to not being able to select a random position outside of the room they're currently in, they'll try to wander in the same room that they're currently in, following much of the same process. If this fails, they'll try to leave. With regard to individual nodes, for example, the calculate path node will do just that. It looks at a centralized blackboard to see where the current destination should be, then uses the custom navmesh agent method of calculating a path a single time before returning that it has been successfully completed. If a path is not possible, it will return failure, and the contingency, as mentioned earlier, will activate. The NPC blackboard is essentially their brain. It contains about 30 key pieces of information about the NPC, which are referred to by a number of different nodes across their behaviors. Since all nodes inherit from the same base class, meaning that any operations carried out will always have the same results of either success, running, or failure. When combined with the centralized data storage provided by the Blackboard, this makes it incredibly fast to add new nodes. As a designer, this was incredibly satisfying as we were able to leverage this during development when the client requested that we bring the behavior more in line with an industry standard of NPC behavior in a management game by adding an energy system. This system was successful in accommodating for increased depth in gameplay, as players now had to accommodate for individual NPCs not becoming bored or tired and then leaving. In addition, we were able to add more fun stuff, so for example, when NPCs get panicked for long enough and lose all their energy, they will die and turn into ghostly artifacts of themselves, which are then visited by other NPCs which panic upon seeing it. This would have been incredibly difficult in the old finite state machine implementation, but in this version all we had to do was add an individual node that turned an NPC into a statue. These systems didn't take long to add, yet seemed to add a lot of depth to the game when we were asking playtesters what they thought. Animations from a code perspective were also relatively simply handled. They used Unity's inbuilt animation tree, called using a reference to the Blackboard, so all it takes to call is blackboard.npcanimator.play and then the animation name, meaning that adding animations for spending money or sitting down was relatively easy from a code perspective. Overall, I was really happy with how the NPC systems turned out. The scalability is the number one thing that I wanted to achieve going from the prototype to the main version, and I think I achieved that to a very high degree given how fast it is to add new behaviors now. The biggest limitation that I ran into during development was the producers rushing me to get the NPCs working within the game. They were very insistent on having a minimum viable product, but I was much more focused on creating a scalable and efficient system. This caused a bit of conflict between the developers and producers, with the developers backing me, wanting the system to be more finalized, whereas the producers just wanted something to show to the client. I held my ground, and I think the final result was worth it. If I'd have used the old version as they'd instructed me to, there would have been a lot of old and new code mixed together, which would have made it A, unscalable, and B, incredibly difficult for anyone that's not me to use, since the old code wasn't commented at all and had relatively non-meaningful variable names. Also, it just wasn't up to industry standard in terms of formatting.
The game feel we incorporated into the game is probably one of my favourite additions to the project, and it is certainly an indispensable element of Curation as a whole. As shown in the video, game juice has been injected into a number of spots, but the most notable include sounds, visual effects, and animations. As shown from the previous videos, Curation features an original soundtrack created by Federico, a sound design student who's worked with us to create an 8-track OST that loops throughout the game. This was supplemented by sound effects used to place emphasis on actions and game world changes, and ambient audio for immersion, which together creates a rounded auditory experience and establishes depth within the game world. Particle effects was also implemented for placing objects and to signify a transaction. This enables us to not only inform the player at times of information that they need to know, but again adds further depth to one's actions and generally makes gameplay more satisfying. Performant VFX was a real concern though, as we needed them to be lightweight enough for low-end devices. So, using a combination of billboard particles and Unity's particle system, we were able to create a lightweight approach that all players of different backgrounds, different devices can play on. However, Gamefeel was subject to a lot of concerns regarding scope creep and time constraints. It was originally planned to create animations for the most valuable artifacts in the game, so they look cool, but this never came to fruition. Due to a team-wide skills shortage, the creation of animations was outsourced to an animation student. Additionally, with the fact that these were requested extremely last minute, we needed to narrow the scope of produced animations heavily, and artifact animations were scrapped in favour of establishing more achievable milestones. The same problem existed with sound, as we had already placed a significant amount of work on Federico. To supplement the lack of skills within this area, however, we utilised royalty-free sound libraries, specifically SoundSnap, which allows us to get as many ambient audio files and sound effects as we could, while also keeping development sustainable in the long run. If we had more time, it'd be awesome to source our own sounds and animations, but I feel with the constraints we had and the lack of team-wide competency in animation, it was a good decision to outsource these, as it meant that active team members could focus their efforts on what they were good at, and it also ensured that our pursuit towards a well-rounded game was not in vain.
Towards the end of the project, we'd met the MVP, so we were able to add a couple of extra systems focused on improving the user experience and engagement within the game. The first was a weather system where every 3 to 12 hours is about a 10% chance of rain, which essentially creates particle effects, has some ambient sound, and changes the lighting within the scene. Similarly, I added a day-night cycle into the game, which changes the lighting position, intensity, and sharpness between day and night. This also gives a sense of time to the player and was well received when playtesters were asked. It brought it in line with industry standard, so players were able to have a grounded sense of when time was passing within the game world. Because of Unity's lighting system, there were issues with colour popping on the wall when the sun reached a certain angle. This makes it look a little unnatural, but the popping is generally unnoticeable and was only pointed out by playtesters once the developers had already shown them it happened. We did look at adjusting the shader graph so that this wouldn't happen, but again, it was too time consuming to be able to do at this stage of development. A rating system was also added to visualize player progression, with the stars mostly based on happiness, but with up to 2 stars available for artifact diversity. This replaced the ambiguous smiley face that was there throughout development, which playtesters would constantly ask the function of. Most people would recognize a 5-star system over an ambiguous smiley face in the corner. Therefore, we found the game to be more accessible for playtesters, especially those without gaming backgrounds. I also added variable NPC spawning, which was based on this rating, but also the time of day with the popularity at each point being defined on a graph, as well as the floor size of the museum so that NPCs wouldn't be too sparsely spread out throughout a giant museum, for example. World space money pop-up effects were added to display users' changing currency, which aimed to give a little insight into their cash inflows and outflows, and help players to understand what they were spending money on. Lastly, the default Unity splash screen was altered when starting the game to match the style from other games within the genre, having the placeholder, admittedly, name of the team show up before the game, as well as the game's title. This was a simple task, but it was explicitly required by the brief.
Now we will have a dedicated section on the artistic features that are present in the final game, which will be presented by our head artist Rob.
In order to best match the overall feel of the game, as outlined in the initial pitch, several key artistic features were prioritized. Assets needed to be kept consistent across multiple artists and themes to prevent a jarring experience for the player. To this end, early documentation included a genericized walkthrough of the standard asset making process, particularly focusing on texture, as the step with the highest potential for obvious differences. As part of this, a bespoke smart material was created in Substance Painter to act as the baseline for any future texture. This included defaults and the use of various mesh maps, as well as basic color correction to ensure adherence to a singular color scheme. This greatly improved time efficiency and inter-theme cohesion, though also somewhat limited freedom and options for the individual artist. It also resulted in minimal differentiation between separate materials and surfaces within the game. All assets were lit and rendered using a custom shader graph built within Unity, utilizing the flat and bright textures created earlier with cel-shaded shadows to create a stylized cartoon-like look. This again aided the comfortable and light-hearted theme of the game whilst allowing for another layer of tone mapping and color correction, which could be edited much more easily than traditional lighting. All art assets were created following a standardized pipeline with regards to software, enabling quick and easy sharing of files between team members, as well as ensuring that any advice could be specific and informed without the need for translation to a different system. It also aided in keeping scaling and axis orientation consistent once imported into Engine, reducing the work needed later on in the workflow. In order to keep the clarity of art assets high, attention was given to the properties of the camera system as existed in the game. This included keeping in mind the isometric angle of the player when orienting and structuring assets, as well as considering the level of detail required for sufficient fidelity given the various levels of zoom available during play. This resulted in the heavy use of large, bold shapes on most artifacts that would be used consistently throughout a given theme. Prehistoric models utilized organic curves and spirals, medieval models were more square and boxy, and extraterrestrial models featured hexagonal and other geometrical designs. Individual themes also utilized smaller subsections of our larger warm color palette in order to easily differentiate between them at a glance, while still maintaining cohesion over the larger scene. While succeeding at this goal, the standard color scheme somewhat reduced the effectiveness of the limited generic decorative assets available in the prototype, as they more clearly don't match their surrounding theme. A higher variety of assets would alleviate this problem in a fully developed game. Technical considerations were also kept in mind during art development. Assets were kept to a reasonably low poly count given the simple style, though did need to stand up to inspection at the high zoom level available to the player. Any polygons never seen, such as the bottom of podiums or interior geometry, were culled. However, further optimization could have been achieved via the use of LODs to account for the variable zoom. Assets also shared portions where possible, primarily the podiums on which artifacts are placed and reused across a given theme, as well as small elements such as leaves and many of the prehistoric models. All NPC characters also utilize the same base model, with only texture differences and randomized props differentiating them, allowing for a simple shared animation system to service all of them. This saves a great deal of development time, though similar to the single smart material, somewhat limits the available creativity as a trade-off. Finally, the lighting used was fully dynamic, in order to allow for the implementation of the day-night cycle as well as the possibility of player-placed placeable lights further into development. This is complicated by the shaded graph's reliance on a singular directional light in order to drive its shadows, with secondary lights affecting only colour. Further development and refinement of the lighting system could potentially require heavy refactoring of the existing shader. However, over the scope of the existing project, this was a non-issue. The shader also notably contains no support for several common PBR maps, including roughness, metallic, and occlusion maps, as these are not actively useful for the game's style. Their removal helps reduce both file size and runtime resources, however, again, their inclusion could open up more possibilities during future development.
After completing our game and sending it off to our client, we then had a large period of time to reflect upon our work and assess the overall outcome and team's performance in this project, including our long post-mortem a few weeks after development ended. Here is what we gleaned from this. Firstly, we believe the project's performance was incredibly positive. We easily met our brief requirements in both the structural requirements, such as the documentation and progress pictures, and our product meeting the specific feature set. Alongside this, we were able to develop the game further, to be more than a simple demo, through achieving various stretch goals such as the fully functioning NPCs, hints, and weather, as well as the game having a mostly completed game loop and having the potential to be played for simply entertainment rather than proving any concept or working tech. Finally, due to the high quality of our game, we are considering and taking further actions to continue this project outside of the brief and its deadline. This includes plans to continue development over summer to add some key features and polish the existing game, potential plans to commercially release this game on Steam under our own company for consumers to enjoy, marketing ourselves in order to have the opportunity to be nominated for awards, and taking this game to various events, such as the confirmed promotion at the Barclays Game Frenzy in London. We came to these conclusions based on feedback from various people, and most notably the feedback from our client Luke Hale at Frontier. As shown from the condensed points here, he assessed our results very positively while noting that the endgame loop is still unfinished, as we did not have enough time to flesh out the balance and progression. Here is the full written feedback from Luke. Pause here if you want to read it in full. When it comes to our team's performance, most of our findings were made in our post-mortem. Starting off, the team was very responsive to their workloads and interacting with the team. This can be shown through our collaboration efforts, where developers would often organize small meetings with each other to work on a feature, and responses were often very quick across the entire team for the most part. This is also highlighted in the post-mortem, where we were able to identify many successes and failures across the project, which made analyzing performance easier, and everyone was very communicative in voicing their opinions and thoughts in a civilized manner. Furthermore, their peer reviews also demonstrate this, as they are reasonably even and were consistently done, providing valuable information to the team members about the areas they excelled in and the areas that need improving. The team structure was also very solid, as regular meetings were conducted every Tuesday and Friday with very high attendance. And our structure for both meetings and development was carefully iterated on over time until we reached a structure that worked for our team, such as how meetings were conducted, the content within those meetings, such as the sprint retrospectives, and the method in which work was merged into the project. This also allowed us to create successive builds each week over the last few months of development, which helped with playtesting and gave a visual representation of our progress. Some of the specific points that could be improved on in the future was the interdisciplinary communication between designers, artists and programmers, which affected the rate at which art pieces were added into the game, where programming and art communication should have been stronger. Burnout was also a problem for the art team specifically during the later stages of development, as the weaker communication led to their workload being both overscoped and unrecognized, which meant time was needed to allocate to rescoping work to a manageable state. Finally, although deadlines were set for various goals such as builds and peer reviews, they were often loose and went over schedule by a range of a few hours to a few days, which wasn't too much of a problem given our team's working style, but could definitely see improvements. Next, we had decently useful project upkeep methods. This was done by using live documentation to fully flesh out our ideas across disciplines, which helped us better inform the team about the project as shown by Ramadan and Widyani. We also made use of the asset and feature lists to document which tasks need completing and what we overall included into our project. Finally, we made heavy use of Jira for our project management to detail sprints, delegate work, and track burndowns. We also made good use of source control through both our documentation through Confluence and project versions through GitHub. However, there was no storage outside for larger files such as models, which we should have created separate source control for. There are larger issues when it comes to these three aspects of our team's performance. For example, the main documentation for design, art, and code was not updated or referenced consistently over development, which was something that needs to be addressed before moving forward. There are also a few times where Jira was not properly updated and tasks weren't accurately tracked, which got a lot better towards the end of development, but could still be improved, and also meant the burn down chants weren't as effective as initially we thought. Finally, source control in both Confluence and GitHub got a lot more messy as the project continued and will need to be cleaned up before moving forward. Overall, we believe the team performed to the best of their ability and did very well for a team with very few prior experiences working together, and we were also very fortunate during development with both the execution of our plans and most external factors which could have affected us. This concludes this presentation and video. We are looking forward to the future of this project and what we can do to take this further. Thank you for watching.